when we have the situation that our graph, like the one I show here, is not crossing the x-axis, we still have two zeros. We still have two roots to this. Zeros and roots being the same thing, but they're not going to be real. They're going to be complex roots. So how do we find those? By setting x squared plus 2x plus 3 equal to 0, and I use a quadratic formula. I mean, we're not going to be able to factor that. In rare cases could we factor it. So we'll just get really comfortable with the quadratic formula. And it looks like our A, this is example 5 as well, A is 1, B is 2, and C is 3. So we would be looking at x equals -2 plus or minus the square root of 2 squared minus 4 times 1 times 3 all over 2 times 1. So -2 plus or minus the square root of 4 minus, and that's 12, 4 times 1 times 3 is 12, all over 2. So -2 plus or minus the square root of 8 all over 2. So -2 plus or minus 2 root 2. Oh, that should be a -8, by the way. Oops. 2i root 2 over 2. And that would reduce down to be -1 plus or minus I times the square root of 2. So the zeros are going to be x equals -1 plus I root 2 and x equals -1 minus I root 2. I'm going to clean this up because it's kind of sloppy. So it'll be -1 plus or minus I root 2. And that's what we get out of that. So that means the zeros for this would not cross the x-axis because the only real numbers are there. So it in effect has these two complex roots. But it has two roots. Now the discriminant is the part under the radical for the quadratic formula. And I don't think we covered this before, so I was going to talk about that now. So if we think about our quadratic formula, it gave me this extra set of parentheses. Let me see if I can clear that out. Well, whatever, I'm just going to leave it like it is. So we have our quadratic formula. The part under the radical is called the discriminant, b squared minus 4ac. And depending on the value of the discriminant, it tells you about what kind of solutions you're going to have. Like in this last one, the part under the radical was a negative, it was -8, and we had two complex because we'd have a real part and we'd have a complex or an imaginary part, which makes a complex number. I mean, really any number can be called complex, but a non-real and a non-solely imaginary complex number. So you have several cases. B squared minus 4ac equals 0. That means you have one repeated rational zero. So the part under the radical is nothing. So it's just going to be -b over 2a. B squared minus 4ac is greater than 0, and it's a perfect square. You get two rational solutions. So, that's what, like square root of 16 or square root of 9, or something like that. But b squared minus 4ac is greater than 0, but it's not a perfect square. You'll still have two solutions, but they'll be irrational solutions. And then you have the other case, b squared minus 4ac is less than 0, which is what we just had, and you get the two complex solutions. So in example 6, we're going to use the discriminant to find the nature and the solutions to the following quadratic equations. So we can look at, we're just going to look at we're looking at b, just the b squared minus 4ac. So in this one, it's going to be 4 squared minus 4 times 1 times 4. And that's going to be 16, I should say, not 4. Come on, erase. There we go. 16 minus 16, which is 0. So this has one rational solution. And I bet you can guess what that is. Next one, we have 14 squared minus 4 times 8 times 3. So 14 squared, I believe, is 196. Minus, and 4 times 8 times 3, I believe, is 96. And that's going to be 100. So 100 is a perfect square, so you'll have two rational solutions. Next one, our b is -5, so -5 squared minus 4 times 3 times -2. So it's 25 minus negative makes it plus. 4 times 3 is 12 times 2. Sorry, alarm went off there, notification. It's 24. So I get plus 24, so it's 49. That's a perfect square. So again, two rational solutions. And then we have -10 gets to be squared minus 4 times 3 times 15. So 100 minus 4 times 3 is 12 times 15 is 180, I believe. Someone can correct me. I'm pretty sure that's what it is. I do have a calculator right here. -80. So that means they're going to be the square root of a negative. So it's going to be two complex solutions. Okay. Example 7 is more of the same. Use a discriminant to determine how many and what kind of solutions the quadratic equation that we have. We have x squared minus 4x plus 10. So again, we look at our b squared, so -4 squared minus 4 times 1 times 10. That's 16 minus 40. So it's going to be -26. So it's going to be two complex solutions. Okay. Kind of a cool tool. And that's it for this part of this lesson.